Just waiting for the recording. Yeah, so the transaction modes, I asked you the question at the beginning. It was asking why why we may talk about why we may present the transaction modes. The transaction modes actually they are ways to define a start and end of a transaction, and not only that, they are ways to define how to commit a transaction or how to roll back in needed cases. So, because if we take the example of the ATM machine, we have so many queries to do in just one transaction. Okay, in between we need to cancel. If the user cancel that, how to do we have to force him to withdraw money? No, there have to be a chance to yes to stop the transaction in between and to roll back the steps. So what has been happened has to be rolled back. So the transaction modes helps us to define that and helps us to achieve such a behavior. So whether to start to indicate the beginning and the end of a transaction, or to deal with how, when to confirm the transaction and to save the effect, or to roll back in needed cases, and even to deal with nested transactions. Yes, we will deal with that. So transaction modes will help us clarify this behavior somehow. So we finalize the work with the assets as properties. If you have any doubt in this, actually, you just raise your questions or your queries right now. Otherwise, let's pass to the transactions modes. We defined what is a transaction mode, and we given the first preview what can be a transaction mode in our cases. We are going to see four modes, but they are for different behaviors. Starting with the first mode, which is the auto commit transaction mode, the auto commit transaction mode, the auto commit transaction mode. This is actually a transaction which is actually made up of one query to do, and this is by default to be commit at the end. Means the transaction has a start and has an end. This is for true. This is for sure. And this transaction would be committed, would be actually admitted by the system, and its impact will be directly set on the system. So whether we are talking on the database, on the entity, on the data, since it is made up of one query, so it is to be set on individual statement. So query by query, the work. The explicit mode here, as per the name, it is explicitly set. So we have to state the beginning and the end of the transaction. This is for sure, yes. And manually, we commit or we roll back the statement. A transaction, sorry, it is a statement to do, but the transaction has queries in between. The beginning of the list of the queries and the end of those queries, there has to be actually manually explicitly set. And the commitment, it has to be the commitment or the rollback has to be stated explicitly. The programmer, the developer, or the system developer, yes, states that the transaction ends with a commit or ends with a rollback. Simply. What is this? Actually, just before I pass a transaction here from this statement here, from this explicit transaction mode, we can understand that a transaction might happen, might be executed and not committed, not saved by the system. Its impact will not be set on the system. Yeah, absolutely. If you talk, for example, about updates or inserts or delete or alter or let's say truncate queries, those queries they are sensitive. And because of that sensitivity, we might have the chance to cancel that. So they do not have to have their impact directly on the database entity or on the object itself inside the database engine. So explicitly to be stated, whether to commit, yes, admit what you did, what you requested, what you executed, or you roll back, you cancel and you come back, you cancel all and you just roll back steps before the transaction, before the statement. Yes, it is like that. So this is for security reason to be raised up. The transactions modes, now we are seeing them acting for security purposes in order to omit deletion activities or updates or truncate activities, queries. We may cancel that, we may roll back. So they would not have the impact directly set on the data object unless explicitly mentioned. The transactions also, they might be implicit. The transactions, they might be also implicit, means here we're talking about the implicit transactions mode, where we see this mode uh, almost having the same properties as the explicit transaction. It has to be mentioned with the start and it has to be ended with either a commit or let's say a rollback. Yet those transactions, they would be implicitly started after a prior transactions has been finished or accomplished. So the implicit transactions, they will be started after a termination of a prior one. So implicitly by the computer, the system will decide to start a transaction when a transaction has, or a list of transactions has been terminated. So this is the row to, so this is the time to start this transaction. This is an implicit mode when the system decides to do. But at the end of the day, the transaction has a start, has a scope, and it has to be ended with a commit or a rollback statement. Any questions at this level? At this level here, any questions please about the transactions modes? No, well, just
No,
finish.
Mister.
Okay, great. We continue. The fourth transaction mode here, I stopped before because I need to take time in explaining this mode here. The Busscoped transactions, the Busscoped transaction mode, or modes also, plural. It is a context via which we are going to state implicitly and explicitly, both implicitly and explicitly, transactions to be executed. At the end of the day, we are going to have a transaction or a list of transactions, nested transactions. Nested means transaction inside the other. Yeah. But they have a scope, means a beginning and end. So what's the problem? The problem is that we are having more than one result that has to be actually raised up and recorded from more than the transaction body. So I having multiple results to be committed and admitted and let's say retrieved and let's say executed at the end within this transaction, this type of transactions, this kind of transactions. So we are not going to make just an update in just one object as per an example. We are going to have two objects, two entities, two DB objects in general, for example, or more, two or more. And those two or more objects, they are within the same transaction body and they have to be controlled. We may commit this and roll back in the other. We may commit both, we may roll back both. You understand? And I'm saying two or both here because this is the list number of the objects to admit. We may talk about a connection string that paths object number one and connection string that paths object number two. We see an example right now in just in a while. Those two paths or those two objects, they were going to be communicated within one transaction. So because of this, we are talking about scoped transaction. And here we need a specific way of specific mode of commitment or rolling back. Because if you commit at the end only and that's it, so we are going to commit all for all connections and for all objects, which is in some cases not the case. We need only to commit one path, one object, one effect on one object, not both or more. So it has to be controlled individually from within the same one transaction. I repeat, one transaction. Technology here defined in the Busscoped Transactions says that those Busscoped Transactions modes, they are applicable only on multiple active result sets. Here I was saying two objects or more. Multiple active result sets, two objects or more, is two results on two entities or more than two entities, two tables or more. Mass, multiple active result sets. Mass, we are talking about mass. Remember the word mass. So I was saying that they are explicit or implicit transactions. Both can be seen here. Both can be seen here. Yes. Let's take an example. Let's discuss an example. Yes. Okay. For the concern of the Busscoped transactions modes, here to control the objects inside whenever they are treated from within a one transaction, we may refer to use time frame save points to control each transaction. What does it mean? For example, we take the example of two only because it gets more and more complex when you talk about more than two objects. Let's take the example of two objects only, means two tables only, for example. We are going to manipulate two objects, two tables, from within one to two different tables, means from within the same one transaction. Okay, we did n queries on the first object and m queries on the object 2. Okay, we're going to admit query 1, then roll admit 2, roll the queries on the object 2, and then after we execute again the activities on the object 1. So what should we do? If we do rollback, simply it will roll all the activities on the object 1 and also on the object 2, both of them, which we don't need. No, it's not the case. So we need some time frame points to use to control. I'm going to give you the example to make you understand here uh, what does it mean, what is the use of those save points. Save, not safe, save points. Okay, great. So we have a transaction that starts here. We have a transaction that starts here, whatever, in this regard. But it's not only that. So here there is a note. There is a note here that the under the method of save points, running back to save points and committing transactions isn't allowed. So there is a constraint here. It's not. It's not. Let's discuss first of all what is the save point, and then after we will talk about applicable or not. So we have a transaction that starts here. So here is slide number 15. I'm going to pass to slide number, I believe, 16 or 17. So 16, yes, exactly. So here, this is the end, and here we are committing at the end. This is the end. Still, all of it from here, the beginning until the end here, one transaction. Okay, we're committing at the end. But in between here, we are having a rollback. It is explicitly set. Explicitly set. What is that? Rolling back transaction to the place where, or to the statement, or to the level where, say, point one is set or defined. What is it? Here it is. We defined here a save point in between that we require to roll back from here, to roll back and cancel those queries here to return to this level. So simple. Now we understand that the save points, they are in the life cycle of a transaction. They are time points. They are time points, and those time points they can be utilized later on for good manipulation of the behavior. I may say good manipulation. Why? Because here we want to cancel those, or to admit to a means to roll back, or to admit both. One of the whatever we want to do, only those queries. So we can do that. So we can apply that. If you press, if you are saying here, roll back to say point one. So those statements and the behavior, the read and head point of the system, we come to this point here, and we continue again. So those queries would be, sorry, those queries would be rolled back, would be cancelled at the end of the day. Let's see an example of a mass, means a multiple active result set. Here we are not having, here we are not having a multiple result sets, multiple active result sets. We are not having. We are having only a list of queries implemented. List of queries. See here from the beginning. Query, 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 query. And again, query, 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 query. All of them, they are queries only. They are just manipulating queries only. And those queries, they are on an entity. Q1. Simple. So these not with the multiple active result sets. So we are having only one entity, and we are just passing simple queries on that entity only. So this is a place where save points may be utilized. So this is a long transactions. Yes, this is a long transaction, one transaction. Yes, and we are seeing more than one, let's say, commitment and mode be executed or called, the rollback and the commit, both of them in the same transaction. Yes, but here it's not a mass transaction. This is not a mass transaction. Let's see an example of a mass transaction here, a multiple active result set based transaction. This one here, it's a transaction that has more than an object manipulated. So before I explain anything here, this mass transaction can be utilized and can be implemented. In this example here, remember that we are dealing with the .NET, we are dealing with the Visual Studio, we are dealing with the SSDT, we are dealing with the SSMI, we are dealing with the SQL Server, and all of them, they are Microsoft based. Technology controlled here, it is running on, let's say, monitored here, the technology are available here for us. It is run on top of the .NET framework. .NET, it is a facility, a technology, a framework that Microsoft has brought to life in order to help all of those technologies to communicate all together. Great, great. So here we are seeing a .NET solution. It's one of the Microsoft famous solutions. It is written in C# only. All of it. It is written in C# only, and interrogating a SQL Server entity. Sorry, SQL Server, yes, DB database. We are having a connectivity to a server, whatever. We are activating a feature, which is the multiple active result set. Yes. Why? Because here we are activating this. Why? Because we'll have two interrogations, two paths to interrogate to go with for interrogation. So see here we are having a command one, and also I pass to the next page where I'm going to see command two. Command one is something which is a simple insert, let's say here, and then after some other activities, the select. The other one, the command two, it is an update or something like that, but on what? T1. We come back to the prior interface where we see the T1 defined somewhere. So here actually we admit that this T1 is an entity from this server here, from the database here, testDB, and it is interrogated with based on the use of two different commands completely for different purposes. Command one will return a result, command one, and command two will return a different result. We are using the same connection, which is this con, which is the connection string at the end of the day. Here. So here we are seeing two different commands to be manipulating an entity. Yes, two different commands manipulating an entity, and at the end of the day, still the content, still the work is going on. If I come to the end, let me come back to the end. I'm going to ask you. I'm going to go to the end. And I'm going to ask you one question. Let's commit, or let's say roll back. Here, the work from within the body of the transaction, it is based on the command name. It is not based on the time frame process. It's not a list of queries to do. No, we are having blocks to execute based on commands. Command one, command two, and so on. So command one will return a result. See here it is. Command two will return a different result. Command two will return a different result. Yes, here it is. So what to commit? What to commit? We are having a body, then after we have an execution, then after we have a termination. So it is not the same preview. If you understand very well here, this process of this .NET solution here, the C# program here, you'll see that the commitment is not, it will not be admitted, or even the rollback will not be having the same behavior. It will not be adopted the same way when we are dealing with one channel, one path, uh, one one object, or one command. Completely two different results here. Multiple active result sets. Any questions, please?
No.
Okay. This is termination, but this is actually an exception handling for the execution of the transaction content earlier. So nothing to explain here. So the transaction response is one of the features that we may refer to, and actually it is to be admitted with long programs or long activities to do. The whatever the mode is, the implicit, explicit, or the partial scope, whatever. It depends on the scenario. Not only this technology, those are properties also, and not only those properties to be adopted to guarantee the execution, the best execution and the best behavior of the transactions, the isolation level is one of the other features. We may say properties also that we are going to adopt, and we have to adopt whenever we talk about the the actually we here we are going to deliver better result. So in order to avoid the duplication, the repeated execution of queries, the repeated call of transactions, so we have to isolate them. Um, the isolation, we defined it when we saw the ACID properties. The isolation said there, defined there, the ACID properties, it is to avoid the inferences or the interferences. Still, it is a concern here, but in this regard, here we are going to avoid more, let's say, more problematic views. Amongst of them is to avoid the repeatable read or reason or whatever, read of transactions, queries inside the transactions, and so on. So isolation levels. Let me give you an example to make you understand what does it mean and what is this thing here. I'll come back to this table just in a while. Let's take the example of the web as a framework. Our EduWave anyway, so this one here, the EduWave, whom are the persons using or the candidates, the customers of this EduWave? All of us, students, instructors, administrators, technical people, all of us, we are users. During the registration period, 2 days or 3 days or 1 week, all the students, University of Niswa, from the 4 colleges, they have to register and they have to get registered and they have to choose their courses and contact their advisors again and again and again and again and again until they finalize their timetables. All of them at the same time. How the EduWave won't fail? Confusion, for example, and instead of saving students one timetable, he saves students two timetable, as per example, with the long and big number of requests, and if there is any similarity in names, for example, or contact or something like that, how the system won't fail. It is not trivial. It is not a consequence. There are secrets here. The number of students and the number of transactions sent at the same time. At the same time, they are big enough to make the system fail. The isolation level, the isolation level, the isolation level, for a reason or another, I give you an example normally how he will not fail in saving students one timetable instead of students two timetable. It's just an example here. But in the abstract view, an isolation level will avoid duplicating transactions or duplicating the read of transaction or changing values with different sessions or and things like that. Taking the example of the deadlock and the serializable isolation level, here you are seeing a mode, or let's say a level, a way, a behavior via which the system is blocking or locking all the activities on an object while a transaction is being raised, is being executed. Yeah, so everything has to be started, executed, whatever the transaction content is, terminated at that time, the next queries or the next transactions or whatever would be executed because the system has locked the process and cannot be interfered or cannot be shared, something like that. Whatever, I can use the word shared. So I'm giving the example here by the serializer, but here just to bring you your attention is that the isolation level, it is a way via which to secure, again, it is a way via which to secure a transaction from the external environment here. It is not only to avoid inferences or interferences, but also to avoid the misbehavior of the transaction itself, the misbehavior, because repeat reading again and again a content from a transaction, it is not to be done implicitly by the system. It has to be explicitly said maybe yes, otherwise it has not to be done. The system does not have to display the data of users without any request. No, it cannot be done, whether the number of the requests is huge or small. So this is not a behavior that can be accepted. So this is to be controlled by what? By the isolation level. If student number one in his computer requests to display his profile, does not the system has to display the profile of all students for all students? No, it is only for the student in his own device. This is to be controlled by what? By the isolation levels. If you